I'm going to do a couple examples of piecewise functions since you guys don't really like these things. Alright, forgive my graphing. It's going to be really hard to do on this thing. First thing I'm going to look at though is my restrictions. My restrictions are right here. This tells me that I have this function only when x is less than or equal to -1. I have -2x when x is greater than -1. So kind of my restriction is right at -1. So at -1, if you want to, make a dotted line just to make it easier on yourself to give these restrictions and kind of split up the functions in your head. So when x is less than or equal to -1, I have 2x plus 3. So only on this side of my imaginary line here, I have 2x plus 3. Well, usually this thing would cross at 3 and go up 2 over 1. But since it can't happen on this side, I'm going to try to go the other way and work backwards to figure out what it looks like over here. Well, from 3 I can go down 2 over 1 then, and I'm right at my boundary. And since I'm less than or equal to, I can go ahead and make a dot there that is filled in. Then I can go down 2 over 1, keeping the same slope from that point. Well, there's a straight line, so there's that part of the graph. Also, I have this part, -2x, when x is greater than -1, so that's only on this side of the graph, so I'm only going to be somewhere over here. Well, -2x, there's no plus b or anything, so I have to hit at 0. -2 is down 2 over 1, so I must hit that point as well. But I need to know what happens at the boundary, so I also go up 2 over 1. Since I'm just greater than, I'm going to leave that as an open dot. So there is that part of the graph. And talking about like the domain and the range of this thing, the domain is all the x values included. Since it goes to the left forever, it's going to go from -infinity. Since it goes right forever, it's going to go to infinity. There's no parts of the domain that I cannot include. However, the range, it only goes up to 2, and 2 is not even included in the function. So everything below 2 is, so I can say this goes from -infinity all the way up to 2, and I'm going to keep it in parentheses because this 2 is not included. For this piecewise function, I notice that my boundary is at 2. So at 2, again, I'm going to go ahead and try to create that little dashed line. So that's what I know is my imaginary boundary. That's where my piecewise function splits in half. There's one part over here, there's another part over here. Then just looking at our functions, I know I have 3x plus 4 when x is greater than 2. So usually 3x plus 4 would cross right here, but instead I can't be on that side, so it's going to cross way up here, and I actually kind of drew this wrong, so that's awesome. You know what, let's change that 4 just to make it easier. I'm going to change it to a, let's say it's a 1, just to make this kind of fit our graph. Sorry. So if I have 3x plus 1, really it's going to cross at 1, but since I can't be on that side of the graph, I have to go up 3 over 1, puts me at 1, do it again, so go up 3 over 1, and it's greater than or equal to, so I can fill in that dot. Get one more point, go up 3 over 1 again, and still this is kind of off the graph. That's okay. So it's going to go all the way up there and kind of break our piecewise and function in half even more. Alright, also, I have this 2x minus 3 when x is less than 2. So at -3, I have an intercept. Goes from 2x minus 3, so up 2 over 1, there's another point, up 2 over 1 again, and it is open because it's just less than. There's the other part of my graph. Okay, now talking domain and range. For the domain of this thing, again I have everything included left to right, so I can say -infinity to infinity. For the range, I go from -infinity up to 1, and it's an open dot. So -infinity to 1, that's a positive 1 rather. And it is open, so I'm going to leave my parentheses open. Also, I go from, it looks like 1, 2, 3, 4, 5, 6, 7, from 7 all the way up to infinity. So from 7 to infinity is also included in our range. Hopefully that helps you guys with piecewise functions. Thank you for watching.